This is one-dimensional collisions, and this is very important for physics, and it's very central to physics, and it's a very important thing. Momentum is always conserved, and so in many collisions, the momentum before the collision must equal the momentum after the collision, even like in the nuclear reaction you see below. And that's the vector form of all general equations. In one-dimensional collisions, vectors are not needed, so you can drop the vector signs. And what you see here are just simple block motion type things that are going to be a good example of what a one-dimensional collision is. Now, if we consider a stationary object, the number 2 momentum can be pulled out of the equation because it's not moving. And that's what this picture, this drawing shows. Now, if we solve for one that we didn't measure, if we measure both masses and the initial velocity of mass 1, we've got everything, and also mass 3, we've got what we need to solve for just the fourth momentum. And it comes out pretty easily to this result. And if you look, the velocities, I should have taken out that middle part there. It's the ratio of the masses times the difference in the velocities with m2 on the bottom. So that finishes everything for the simple case where it's an elastic collision, where you do not have any change in energy or any other effects like stickiness or deformation. And this starts a real simple inelastic collision, which is not much different from the elastic one. The picture here shows the case before and after. And when you have this, you only have 2 momentums in the situation. So what would be the third one's value or expression? And here's what it turns out to be. It's just a change in the mass that's in the third momentum. You've got the total mass there where you just have one of the first mass that's moving to start out with. So when you rearrange things, the third velocity, or the final velocity, is m1 divided by the total mass. That's what that sum's all about, times the initial velocity, which is velocity 1, which is again a fairly simple result. Both of these kinds of reactions